Hello friends, so in today's question, find the maximum force for which they can move. So we have two examples here. So in the first case, the weight is given 2 kg and 3 kg. In the second case, the weight is 2 kg and 8 kg. And the coefficient of friction between 2 and 3 kg is given as 0.5. And this is surface. And here, let us call this as mu1. And here the mu2 is given as 0. And in the second case, this is mu1 and its value is given as 0.2, and this is mu2 and its value is given as 0.3. So we are going to find out what will be the maximum force which is now being applied on the mass of 2 kg which they can move. Okay. First of all, for let us consider A. So in this case, this is our 2 kg block and this is our 3 kg, and force F is being applied on the 2 kg. So because of that, this 2 block will try to move the block of 3 kg in the forward direction with the help of friction, and let us suppose the friction force is given as F, and as a result there will be a force of friction or equal and opposite force which will be acting on block number 2, or rather with a block having mass 2. So you can say that the applied force F will try to move the block of 3 kg towards the right, with the force that is actually force of friction, and let us suppose that is given as F. Now let us consider mass of block 2. Okay, so this is mass of block 2 and we have a force acting in this direction and frictional force F in the opposite direction. So we can find out the maximum force of friction, the maximum frictional force let us call this as F max, which will be equal to mu n. Okay, this will be having mg in the downward direction and there will be normal in upward direction, mu n. So mu is given as 0.5, so we have 0.5 into 2. G is supposed to be taken as 10 meter per second square, so we have 10, so we get F max as 10 Newton. So it means this will be also the maximum force which will be acting on the block having mass 3 kg towards right. Therefore, maximum force acting on block 3 kg will be equal to F max, which will equal to 10 Newton. And if we can say, let the maximum acceleration of block 3 kg is equal to A max, and which will be equal to F max divided by mass divided by mass is 3. So F max is 10. So the maximum acceleration will be 10 meter per second square. This will be maximum acceleration. Okay. Now we assume that both blocks are moving together. Okay. We can say assuming, we can say let both blocks move together. Okay. If both blocks move together, total mass will be now 5, and let us suppose F is the maximum force with which it is pulled towards the right direction, and we already know that the acceleration with which it can move, maximum acceleration rather, A max is given as 10 by 3, and there is no force of friction because this is our ground and this is mu is given as 0. Okay. Let both blocks move together, then move together, the maximum acceleration will be equal to A max, and that will go 10 by 3. So we get F max will be equal to mass into A max. Mass is 5, A max is 10 by 3. So we have maximum force is coming as a 50 by 3 Newton. So this is for first part. The second part, we have a 2 kg and then we have 8 kg, and now the force is being applied on the lower block, and it is given here mu2 is 0.3 and here is mu1 is given as 0.2. So let us find out the maximum friction that can act on the respective joints. So this is B. Let us consider 2 kg block. This is 2 kg, and we have, and this is our 8 kg. This is moving in forward direction. So this force will try to move the two body block in the forward direction. Let us suppose it is F1, and therefore there will be opposite force of F1 on the 8 kg block, and there is a friction here also, and let us suppose that is given as F2. Okay. We can say that the force on the block 8 kg will try to move the block of 2 kg towards the right, with a force, and that will be nothing but force of friction. Let us suppose that is F1. Okay. So we can find out the F1 max. So let us draw a free body diagram for 2 kg. So we have F1, okay, and there will be mg, and there will be normal n1. So we can say that F1 max is equal to mu into n1. Mu is given as 0.2, n1 will be mg, and g is taken as 10, so it means it will be 2 into 10. So we get F1 max as 4 Newton. Similarly, we can find out for second one also. Okay, let us suppose that is now there will be mg in the downward direction n2, and there is a force F, and there is a F2, and obviously there will be F1. So here n2, we can write this as F2 max is equal to mu into n2. Mu is given as 0.3, and n2 will be mg. Okay, so n2 will be equal to, let us write capital Mg, where capital Mg, capital mass, will be equal to summation of 2 and 8. So this will be 2 plus 8 to g, that is 10g. So this will be 10 into 10, and which will equal to 30 Newton. So let us suppose now this so we have that the maximum acceleration of 2 kg block, let us suppose it is A max. So let A max is the maximum acceleration for block of 2 kg. Okay, so we say that we have a block of 2 kg and we have force F1, okay, and it is moving with the acceleration of A max. So we can find out that F1 max will be equal to 2a max, and F1 max is given as 4, so we can say that a max, maximum acceleration, is given by 4 divided by 2, which means acceleration maximum will be equal to 2 meter per second square. Now we once again assume that both the blocks are moving together. Okay, assuming let both blocks move together. So we have this F max, and it is 10 kg, and here will be our F2 max, and maximum acceleration it will be moving. Let both blocks moves together with a max is equal to 2 meter per second square. From here we can write that F max will be equal to F2 max is 30, F max minus F2 max is equal to 10 into A max. We get F max is equal to A is given as 2, so this will be 20, plus F2 max is 30, so we have maximum force is given as 50 Newton. In the second part, the second question rather, we have two blocks, 2 kg and 4 kg, and the force is applied on the both the blocks. In the first case it is 20 Newton, 30 Newton. In the second case it is 5 and 25, and the weight is 5 kg and 10 kg. Okay. And in the first case the mu1 is given as 0.5, and with respect to here also it is given as mu2 is given as 0.2. So let us solve the A part first. Okay. So in this case, first of all, let us assume that there is no friction between 2 kg and 4 kg. It means mu1 is equal to 0. Okay. Let us assume that mu1 is equal to 0. If mu1 is equal to 0, then we can find out separate acceleration of 2 kg as well as 4 kg. So we can say that acceleration of 2 kg is equal to the force of 20 Newton divided by 2. So this will be coming as 10 meter per second square. And for the second case, we have only assumed that mu1 is 0, mu2 is present. Okay. So in that case, acceleration for 4 kg will be equal to the applied force, that is 30 Newton, minus we have the force of friction, okay, and that will be coming as we have 0.2 into 6, okay, into 10. That means here will be coming as 0.2 into 6 into 10. This will be coming as 12. So this will be 30 minus 12 divided by 4, which will be coming as 9/2 meter per second square. So let's draw the diagram also for it. Now we have assumed that mu1 is 0. So if mu1 is 0, so under this what is going to happen, the block will be 2 kg will be, but because of friction, the various forces that will be acting on with respect to 2 kg as well as 4 kg, we can define them very easily. Okay. So let us say, let both blocks are moving together. With the acceleration with an acceleration capital A. Okay. So let us draw the free body diagram for it. So we have this 2 kg and we have this 4 kg and a 20 Newton force is being applied on it. Okay, so because of this there will be F2 in this direction and we have F2 in this direction. Okay, now we assumed that they are both moving together, so the total weight now will be 6. Okay, the force will be 20 and there will be 30 Newton and it will be moving with the acceleration of capital A, and there will be frictional force in the opposite direction that will be of 12 Newton. From here we can find out value of A. We can say that A will be equal to 50 minus 12 divided by 6, and that will be coming as 19/3 meter per second square. Now for block 2 kg, for block 2 kg we have 2 kg and a force of 20 Newton, and we know that it will be traveling with the acceleration of A, and there will be force of friction F2 in the opposite direction. So we can find out that 20 minus F2 divided by 2 kg will be our A, and from here we can find out our F2. So F2 will be coming as 22/3. Okay, so this F2, it is nothing but the minimum friction, is a minimum friction which is required for the acceleration of 19/3, and we find out F2 max, and F2 max will be coming as 0.5 into 20, and that will be equal to 10 Newton. So you can clearly see that our F2 is less than Fr max, which means both will be moving together. Both blocks will move together. And the acceleration will be 19.3 meter per second square. Sorry, I missed it. So we find out F2 max, which is coming as 0.5 into 20, that is 10 Newton. We clearly see that F2 is less than F2 max, and it means both the blocks will be moving together, and the acceleration with which they are going to move is together with the acceleration of 19/3 meter per second square. Next is B. In the B part, we have a 5 kg block, and this is 10 kg. Force applied on above is 5 Newton and on the below is 25 Newton, and the force coefficient of friction here it is given as 0.5, and with this is given as 0.1. Okay. So once again we see that, let us call this as mu1 and this is mu2. We suppose that mu1 is equal to 0. If mu1 is equal to 0, we can find out the acceleration of 5 kg block. 5 kg block will be, and that will be 1 meter per second square, and acceleration of 10 kg will be equal to, you can find out for 10 kg, this is 10 kg block, force is 25 Newton, friction is coefficient of friction 0.1, so we can say that this F2 will be coming as 0.1 into weight is 15 into G is 10. So this will be coming as our 15. We can say that this will be 25 minus 15 divided by 10, which will be getting as 1 meter per second square. So in this case we see that acceleration of the upper block, which is without the friction, is equal to acceleration of the lower block. Okay, see that acceleration of upper block is same that of lower block. So simply we can say that acceleration of 5 kg, which is without friction, is equal to acceleration of 10 kg, which is with friction. And the important thing is that the friction only takes place when there is a relative motion between the two bodies. Okay, so we can say that here friction is only present when there is a relative motion relative motion between two bodies. So in this case, the acceleration of 5 kg and acceleration of 10 kg is same, so there is no relative motion as such between the two bodies. Okay, so we can say that this means there is no friction between 5 kg and 10 kg. Now once again, let us assume that both the bodies are traveling together. Okay. Let us assume both bodies, both blocks move together. So if they move together, their weight will be 15 kg, and we have two forces, 5 as well as 15, and there is a friction force 15 Newton in backward direction, and it is moving with an acceleration of 1 meter per second square. Sorry, we have to find out A, my mistake. Okay. So from A we can find out that A will be equal to, we have, this is 25, it is 30 minus 15 divided by 15. So it means A will be coming as 1 meter per second square. So indirectly you can also prove same thing, that both the blocks will be moving with the same acceleration, as there is no relative motion between 5 and 10 kg, so they will be moving with the same acceleration. We can see that they both move with same acceleration. Thank you.